Welcome back. In this video we're going to be looking at arrays. So we've seen so far that we can store information in our variables, so we can have things like int a, int b, double c, car d, and so on. Now, whilst this is good, this only allows us to store one variable, one value at a time. And with a lot of problems, we usually want to store a collection of data. So you can think about this in terms of scientific or engineering problems. Think about having for example, weather data. You don't just take one point, you take lots of points. Or if you want to talk about the stresses on a bridge, you're talking about multiple points. And because of that, we usually want a collection of data. And usually it's going to be the same data type. So this is where arrays come in. So it allows us to make a structure that contains different values, but all of the same data type. Okay, so for example, I might need 7 ints, or I might need 12 doubles, or I might need 1,000 cars. Okay, so keep that in mind, and let's look at how we create these arrays. So basically, we're only going to look at one dimension at the moment. We can also have our data in 2 dimensions, 3 dimensions, 4, and so on. We'll just look at one dimension right now. We will get to 2-dimensional arrays later on. Alright, so to create an array. So to create a single variable, we write something like this. To create an array, we write the type of our array, then the name of the array, then square brackets, and then the size. Okay, so here I've got an array of 10 ints. Okay. Now, for what we're doing so far, this won't be a variable, and we'll talk about why it won't be a variable. It's going to be a literal right now until we start talking about memory allocation. Okay, so just keep that in mind. So in terms of looking at this as blocks of memory, our A looks something like this, where our B looks something like this. Now it is a little bit more complex than this, and we will learn about the complexities of arrays a little bit later. Okay, so once again, this is a simplified diagram. We'll look at the proper diagram a little later. So in A, I can only store one value, and if I want to add another value, it just overwrites that value there. Where with B, I can insert values in different positions, I can overwrite values in different positions, and so it allows me to store a lot more information, but that information all needs to be int. Okay. You can create other arrays, so I could do double C 3, let's say, and that would create an array of 3 doubles. So I could have 2.4, 1.8, 6.2. Now, let's just focus on our B for now. And the very first thing that confuses a lot of students is the indexes of our arrays. And this you need to be really careful about, and you need to think about it constantly whilst you're learning. So this spot here is at index 0, then this is at index 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay, so you'll never see an index as the size of the array. So there is no index 10. And this is where most students make mistakes early on when learning arrays, is that they'll try and access this 10th index, which doesn't exist, and their program might crash or cause some unexpected results. Okay, so the last index is always one less than the size of the array. Okay. Now, what we want to do is have a look at two things. So let me just clear these because we haven't done that yet. We want to look at two things. We want to look at storing into an array and retrieving. Okay, so storage and retrieval, if we remember right back at the start. So if I want to store something, then it's going to be on the left-hand side of the assignment. And I'm referring to this array, but if I say I want to store 4 in there, where do I want to store the number 4? I need to pick an index. So let's say I pick index 2. Okay, and I'm going to store the value 4. Okay, so in index 2, it's going to have the value 4. Now, I'm just going to give A a value as well, so I'm going to give A the value 3. Okay, so the value inside of these square braces when we're storing doesn't have to be a literal. We could do something like A, okay? And this is going to store 5 in index 3. It also could be an expression, so I could do A plus 1 is, say, 17. Then A plus 1 is 3 plus 1, which is 4, so that will store 17. Now, my advice is be careful with this, okay? If you end up with a negative value here, or you end up with a value greater than 9, your program might crash, or you'll end up with unexpected results, okay? So be very, very careful if you start using a lot of arithmetic when specifying your indexes. Now, we can also retrieve information, okay? So, for example, let's introduce a new variable called C, and I want to store in C what is at index 2, okay? So it means that I'll evaluate this, so we go there, we get the 4, and we go store that in C. Once again, I can do some arithmetic, okay? So the values are going to be evaluated. B3 is 5, so I've got 5 plus 1, which is 6, and that would overwrite what's in C. Now, we can also do things like this. So I can go, say, B2 becomes B3 plus B2. Now, remembering that our right-hand side gets evaluated first, we have to get the values, okay? So B3 is going to be 5, B2 is 4. We evaluate this, so that comes out as 9, and then we store it. So we'd store it in B2 and override it. So we get a 9 in there. All right. So you can play around with this and learn different ways to do it. And this is the basics of storage and retrieval. And we'll look at initialization in the next video, and then we'll look at using arrays with for loops. All right, that's it. Thank you.